Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to introduce one of the comic sections, the parabola. So I've got a picture over here, and parabolas have kind of like this type of shape to them. They have a special point here called a focus. In this example, we're going to imagine this is the point 0p. This is called the vertex of the parabola. For this example, we're going to assume that's at 0, 0. They have a line here that kind of governs the symmetry here called the directrix. In this case, the directrix would be y equals minus p. Oops. All right, now here's how the parabola is defined, or what it actually is. It's the set of all points on the curve such that this distance right here, which I'm going to call d1 here, is equal to this distance. Now my picture was just drawn by sketch here, so if they don't look quite the same, humor me on that. And what this will allow us to do, this definition here, is to write an equation that describes the parabola. So this distance d1 here is equal to the square root of, by Pythagorean theorem, we have x squared. And then this distance here would be p minus y. And the reason is because in green here, from here to here is p, from here to here is y. And then green minus red would give us that vertical leg there. Now, d2, well, from here to here is y, and from here to here is p. So d2 is equal to y plus p. And again, the parabola is such that, it's defined as such that the set of all points here in the plane where d1 and d2 are equal. So what we'll do is we're going to set these equal to one another. Square root of x squared plus p minus y squared, whoops, I forgot my square there, equals y plus p. We're going to kind of see where this leads us here. So if we square both sides, this is going to read x squared plus p minus y, the quantity squared, equals y plus p squared. And then x squared plus, if we expand this out, that's going to be p squared minus 2yp plus y squared. Expanding this one, we get y squared plus 2yp plus p squared. And let's see, you'll notice that these sum to 0. I can subtract this off. Or I should say, you can subtract y squared from both sides. You can subtract p squared from both sides. And what we end up with is x squared is equal to, and when we add this term to the right, we get 4yp. Solving this for y, we're going to get 1 over 4p times x squared. This equation is very important. This is the equation for a parabola with the vertex at 0, 0. Whatever p is, that would tell you the coordinates of the vertex. It would also tell you an equation for the directrix. Now, this is centered at the at 0, 0. I can modify this for shifts, and we could write it like this: y minus k, I'm going to put it in parentheses, equals 1 over 4p times x minus h squared, whoops, the quantity squared, for a vertex at the point hk. So when you're plotting parabolas, the idea is to try to write it in this form. Whatever number is here, that will allow you to find p. That will tell you basically where the vertex is. Now, if you're at the point, if the vertex, p will tell you where the focus is. Vertex is at the point hk. P is the distance, in this direction or the other way, depending on the sign here. That will tell you where the vertex is. Right? So the idea here is you take any sort of equation that you think is parabolic, write it in this form, identify the h and k, that will tell you where the vertex is, identify the value for p, that will tell you where the focus is with respect to the vertex. And I think what I'll do is I'll save this for, I'll save the examples here for another video. So I hope this is a reasonable introduction to the parabola. Have a great day.